All right, what's happening? Okay, now 7-1 notes is rational exponents. And let's start with stuff we know. Now, the square root of 4. Well, what number times itself is 4, and that is 2. Now, the square root of negative 4, we say is no real solution. Now, we know how to work with i's, but in this chapter, we're not going to focus so much on imaginary numbers. We want to focus on the other properties involved. Now, the reason it's no real solution because the definition of a square root is what number, say the square root of x. So what two numbers times itself equals x? Well, that's impossible. How can you multiply the same number to equal a negative number? One would have to be negative or one wouldn't. They wouldn't be the same number. So that is not allowed. Now, that's why you can't take the square root of a negative number. Now, over here, the cubed root of 8. Now, this is a new notation for us. With square roots, there's a 2 out here. We just never write it. Kind of like x to the first power. We never write the 1. A square root references a 2 squared. Now, a cubed root of 8, well, what times itself 3 times equals 8? Well, 2 times 2 times 2. So that's a cubed root, kind of like here we have 2 and 2. Here you would need pairs of 3s. Okay, if we would do our factor tree. All right, if you think about it, 4 and 2, 2 and 2, this wants 3 of them. All right, so it's 2. So let's say we have the cubed root of negative 8. Now, when you have an odd power, this is allowed, because what this is saying is what 3 numbers times itself equals, in this case, negative 8. Well, negative 2 times negative 2 times negative 2 equals negative 8. So the cube root's allowed because there's 3 numbers that exist that give me that result. All right, so that's why if you have a negative, an odd root, okay, it can be negative. But an even root will never work out because it has to be the same number to be a perfect square, or in this case, a perfect cube. All right, so let's look at some other. 3 squared is 9. So the square root of 9 is 3. It goes either way. Negative 3 squared is positive 9. 3 to the third is 27. Therefore, the cubed root of 27 is 3. And negative 3 to the third is negative 27, because it would be negative 3 times negative 3 times negative 3. All right, just some properties that I'm going to reference throughout the lesson that we need to be familiar with. All right, now, radical notation, a lot of times is going to come in this, and this is the general form. Okay, to the nth root, a to the m power. Now, 9 out of 10 times, this is what it's going to look like. Or sometimes we see it in this form. The nth root of a all to the m power. Regardless, if you were to write it in exponential form, or as an exponent, it would be a to the m over n. Alright, so kind of like up here, okay, we have the square root of 4. It's kind of like 4 to the first power. So the square root of 4 can also be written as 4 to the 1/2 power, m over n. Alright, so let's practice this. So let's say, write as an exponent. Okay, so write as an exponent. So I'm going to give it to you in radical form, and I want you to write it as an exponent. So the cubed root of 11. All right, well, my n value is 3. My m value, it's raised to the first power. We just don't write it. So we could write this as 11 to the 1/3 power. All right, what if I told you the 4th root of 4 squared? All right. And I said write as an exponent. So we have 4 over m over n. Well, my m is 2. My n is 4. Well, 2 over 4 is 4 to the 1/2. We could evaluate that further, but for now we're just writing it in exponential form. So what if I had the 6th root 8 all to the 2nd power? We would have 8 to the m over n. Again, we could reduce further, but we're just practicing. And then I have the cube root of x. Well, we could write this as x. My m is just 1. My n is 3 to the 1/3 power. So if I give you the radical form, be able to write it in exponential form. All right, today I'm just kind of laying the nuts and bolts, the groundwork, so that we can move forward. Now, what if the directions say write as a radical? So in these first examples, I had you go from radical form to exponential form. Now I'm going to make you go from exponential form to radical form. All right, so if I gave you 5 to the 1/2 power, it's not really raised to. All right, well now my m is 1, so 5 to the 1st to the nth root. We could just write this as the square root of 5. When again it's the square root, we can just write it like that. All right, you can reference yours, but I'm going to scroll down so we can't see it. So m over n, m over n, m over n. M's on the inside, n's on the outside. All right, so what if I gave you 6 to the 2/3 power? Well, we have root 6, 2 goes with it, 3 is my nth root on the outside. And x to the 2/5 power, just because it's a variable, we don't treat it any differently. All right, so I have the square root of x, 2 to the 5th root. That's a 5. Sorry. Well, let's make it neater. All right, so be able to take from radical form to exponential form and from exponential form to radical form. All right, now what are we going to do with this? Well, we can evaluate expressions with this. Okay, so let's say up above we had the cubed root of 8. All right, so I could go 8 is 2 to the 3rd power to the cubed root, and those in a sense like cancel each other out, right? Think of if you had the square root of 16. So there's a 2 out here. Well, 16 is 4 and 4. That's why when we break down the factor trees, we always found a pair. So like 4 squared to the nth root to the square to the second root would just be a result of 4. All right, so that's kind of how that works. The cubed root of negative 27. Now, some of us can do it in our head. What times itself is 27? If you ever get stuck, just break it down. You got to find 3 pairs. 9 and 3, 3 and 3. There you go. And it's negative, so it's really negative 3 times negative 3 times negative 3. So negative 3 is my result. Now, what if I go 16 to the 1/4 power? Well, it's the 4th root of 16. Well, again, now we need pairs of 4s, right? So if you went 4 and 4, 2 and 2, 2 and 2, 1, 2, 3, 4 2s, give me 2. So just like the factor trees in Algebra 1, but now we're not always finding pairs. All right, what about 4 to the 3/2 power? All right, so sometimes, let's write it in radical form just for some good practice. So I could have 2/4 all to the 3rd power. Now you see how I did that? Now, what's the square root of 4? 2 to the 3rd power, which equals 8. So what I do is I wrote it in radical form. Even if you wrote it like this, you're kind of like, you would multiply that out, okay, and then break it down. But if you rewrite it in our other form, it makes it a little easier. You know the square root of 4 is 2, 2 to the 3rd is 8. So there's not always a set in stone procedure to solve these. There's different ways. So let's look at one more. 8 to the negative 2/3. Right? And note, I'm doing this all without a calculator. Just saying. So we know how to get rid of negative exponents. We got to bump to the basement. 8 to the 2/3. Now, how could I rewrite 8 to the 2/3? Well, I'm going to take the cubed root of 8, because I know the cubed root of 8, so I recognize that, all squared. So we know the cubed root of 8 is 2, and 2 squared is 4. All right, I know it takes some getting used to. Tomorrow in class, I created a handout that we're going to practice this before we move forward. But the good thing is there's always one way you can check. Now, your calculator does evaluate this. I expect you to know how to do it like this. Okay, I will ask that we know how to do it by hand without a calculator. because understanding these properties, getting from here to here is vital. All right, you need to know what's up. Now, but let's say on your homework, when you're practicing, you have your calculator. So how could you do it? Let's say we had the cubed root of negative 27. Well, in your calculator, you need to understand that that's negative 27 raised to the 1/3 power. All right, so in your calculator, you put parentheses negative 27 caret key raised to the 1/3 power, enter, and it'll give you negative 3. So it's a good way to check your work. So you have the 4th root of 16. Well, this is just 16 raised to the 1/4 power, and it'll spit out 2. All right, up here we had this. All right, so you could go 8 raised to the negative 2/3 power. And it'll give you 0.25, which you can math frac to get 1/4. So the calculator is a powerful tool in our practice. But again, you have to know the rules. You have to be able to know what's up and go from radical to exponential, from exponential to radical. And most importantly, understanding that, hey, this is 2/3. I know the cubed root of 8. Probably a good place to start and go from there. All right, so something new, but combined with some stuff we know. All right, well, we'll take questions in class tomorrow and get some practice. And thanks. See you tomorrow.